The QN90A is Samsung's 2021 flagship 4K TV, and new for 2021, the TV uses a mini LED backlit system as opposed to the traditional LED backlight. This change has some noteworthy benefits like significantly more full array local dimming zones, a slimmer design, and also better contrast and color performance. At least that's what should happen. So in this video, we're going to do tests of the full array local dimming system, the motion enhancement, the chroma performance, as well as many other tests, so stick around. Hey guys, it's the Villaman here, home theater enthusiast and lover of all things tech, and today we're testing the screen performance of the Samsung QN90A. Now, for every TV I review, I like to do a screen test video, which is a standard process I've developed so we can see how TV compares to each other and how they compare as the years progress. And since I did these exact same tests on Samsung's 2020 Q90T, I'll be comparing how the QN90A performs against the Q90T, as well as a more traditional comparison against the C10 and also the C1 OLEDs. And if you've seen my comparisons in the past, then you know exactly what you're in for, and it will be a treat. Now, to do the screen test, I used the Spears & Munsell benchmark disc, and in the video you'll see where the TV has some picture anomalies like some moire or screen door effect, but that's entirely caused by the camera. It did not appear in person. Alright, let's get into it. First, we'll start with a test of tone mapping, and we can see that the TV does a good job of ramping from the dark section to the brighter section, but there still is an issue where there is not much separation between the brightness of the two brightest sections, even though there is a slight difference. On TVs with really good tone mapping, there is more definitions in the brighter sections than what we see here, but it still does a good job. The TV doesn't do so well though in the brighter section of the tunnel test, where there is no definition in the brighter sections. Now let's move on to a test of panel uniformity using a full field gray screen. The panel looks really uniform and there is no sign of dirty screen effect, but there is some vignetting around the edges of the TV, which is something I haven't seen in previous QLED TVs. It's not enough to be distracting, but it is there. Now let's move on to the really challenging test, the star field test. The star field test involves multiple bright point elements moving across the screen and can often wreak havoc with a full array local dimming backlight system. And the TV does pretty well in the initial test with not much blooming occurring, but in the subsequent more difficult tests we can see that there's a lot of blooming still happening. The TV also took a while to transition from one star field test to the other, so there is some black crush happening when the test begins, when the stars are at their lowest luminance. Again, this test is really difficult for full array local dimming TV, and I haven't seen any full array local dimming TV that does this test without some blooming occurring. Next is my custom-made full array local dimming test, and in the initial portions of the test, while the dot moves across the screen, there is a noticeable amount of judder that it creates, as well as some ghosting. Also note that I increased the exposure of the camera so we could better see the blooming as it happens. It's not as pronounced in person. The 65-inch QN90A has 44 horizontal and 18 vertical dimming zones for a total of 792 local dimming zones. This bright bar on the bottom, which is meant to simulate closed caption, results in a fair bit of blooming. In this next test of geometry, which is another challenging scene for a full array local dimming TV where there are bright lines on a dark background, this test does create a fair bit of blooming around the lines, but it's also pretty good that the TV has enough backlight zones so the middle of some objects are completely dark without any blooming occurring in those sections. In these next chroma zone plate tests, we can see that there are no real issues with chroma representation. What we do see though is that the left and right edges are darker than the center because there is some chroma roll-off happening. In TVs with aggressive full array local dimming algorithms, the corners of these white squares would have vignetting, but that isn't the case with this QN90, which maintains the uniformity of the black rectangles while maintaining the brightness of the white ones. Next is the quantization artifacts, which tests the TV's ability to smooth out gradients on an 8-bit and 10-bit source. And there is noticeable posterization in the 8-bit source where you can see the steps between colors, so there is some room for improvement. The 10-bit source though is much better and has a smooth gradient. Next, we'll test the TV's motion interpolation capabilities using fast-moving text scrolling from left to right. And with motion enhancement disabled, the text and images on the lower part of the screen are illegible. That changes though when we enable blur reduction. The text and images become a lot smoother and thus more legible, but it does come at the expense of imaging artifacts which appear on the edges of objects, which you can see in this example. Having this setting enabled is great for fast-moving content like sports. Next is the running peppers test, which is a great test of both blooming and also judder, and we can see that both of these are present. And because of how fast the peppers are moving across the screen, the blooming actually trails the object on screen because the backlight seemingly can't react fast enough. Enabling the de-judder setting actually does a really good job of smoothing out the judder that appears in this test, but it could result in the soap opera effect on normal content. Next, we'll test Samsung's ultra viewing angle technology, and in off-axis viewing there isn't much of a color shift, but there is a noticeable loss in brightness and some loss in contrast to a lesser extent. This performance though is very good for an LED backlit LCD TV, though maybe not quite as good as it has been in previous years. Next, we'll see how the TV handles bright room viewing by aiming my studio light directly at the screen at full power, and the TV does a very good job at rejecting the light. The anti-reflective coating and the brightness of the panel combine to minimize the amount of ambient light rejected back at the user. So even when compared to viewing in a dark room with no ambient lighting, it does really well. The input lag in game mode is very impressive. At 4K 60Hz, it's about 10 milliseconds. At 120Hz, the input lag is about 6 milliseconds. One thing these tests made clear is that the QN90A has some really impressive contrast performance, and that's thanks to those 792 local dimming zones. That said, there still were some issues, I think, with the full array local dimming algorithm, which resulted in some blooming, but I think there is definitely room for improvement. LED backlit LCD TVs or even mini LED backlit LCD TVs will typically always have blooming because of the nature of the technology. It's just a matter of how much, but this TV in certain instances didn't have much at all. Sometimes it did, but sometimes it got really impressive. Input lag on the TV is also incredibly low, so it's great for gaming. I can't wait to see how it performs against the LG OLEDs, which are also very good gaming TVs. That said, I recently built a mini ITX gaming PC, which is incredibly fast, so let me know if you guys want to see a gaming test using consoles or a PC, or both. Let me know in the comments. But yeah, those are the videos upcoming on this TV as well as the full review. So definitely stick around for that and subscribe if you haven't. So don't forget to like the video if you liked it and subscribe if you haven't. Thanks for watching, and until next time, this has been your friendly neighborhood Villaman saying be safe and peace.